Good day, everyone. I welcome you all to another episode of our water supply system tutorial. In today's video, I will be proceeding to the water supply system for suspended flows. In our last session, where we did the water distribution, our major concern was about the water main. So here is the layout we worked on, and from our water main we connected to the conduit valves, which from our conduit valves we have our internal networks within the wall. So however, if we have suspended floors, either first floor, second floor, third floors, and in some cases up to 10th, 30th floors, so the major concern in this instance is the riser. And as I've explained, riser is the pipe that brings the water main from the ground floor if you are using ground floor distribution, or from the roof if you are using roof distribution. However, there are two other concepts attached to this system design. So the first concept is the riser diagram. Here is a sample diagram. Sometimes you might be required to draw the riser diagram for your project. For instance, this is one of our projects we did late last year. So we're having an overhead tank like this. So from this our overhead tank, we are now having our water distribution. So this line that goes like this from the ground floor to the first floor is the water riser for the second floor here. We still have another water riser here to the first floor, so it's called the riser. So some project might require you to draw this riser diagram. So riser diagram is similar to the other concept I will be explaining, which is the isometric diagram. For isometric diagram, what it really implies is that looking through here, we're having our top view, but in isometric we'll be having a 3D view. So isometric diagram is just to show how the riser will be placed on the drawing plans. However, isometric diagram can sometimes be complicated, why you'll have to draw. But this is just the simple layout, and this layout is very important for site engineers to locate where the risers will be installed. So let's go back to our project design, or let's look at this on the ground floor. So for the isometric, I've changed the plan. So I've changed it to isometric. So I've changed it to southwest isometric instead of the top view. So let's proceed to the design we are working on. So on our building layout, we proceed with the same process. And you need to bear in mind, for this project, we already have our duct, which the architect planned for our water riser. But the approach I do use is that I will have my main. So I will use a deep circle to denote it. Let me open one of my recent projects. So here is a recent project. I even submitted it earlier yesterday. So this is what I do use to denote my riser. Control C. So coming back to our training video, so we place our riser here, Control V. So from this our riser now, we'll be able to terminate our main for the building. So let's press L enter. This is our pipe. So let's assume our main will enter through this axis. So as the engineer, you'll be the one to specify the best position for the main. So from this our main now, we'll be able to design for the internal network. So let's assume this is our main, although this place seems bugging. So let's change our main axis to this plane. Okay, delete, L enter. So here is our main. So from this our main now, we have our internal network. L enter. So we have a network that is connected to our WC over here. while the same network will be extended towards the axis inside the wall. L enter again, F3. So network goes towards the axis and we terminate it here. So we link this our storage tank, water heater, storage tank, water heater, while we also link this our other WHB. L enter. And from the storage heater again, we will be able to develop the hot water network. I will even provide this one to come like this. So we'll be able to create our hot water network here. Fillet or chamfer. Chamfer. So we'll create our hot water network by changing the layer. Okay, so L enter again, and our network goes like this from our hot water to our WHB, while the other one terminate at where? At the shower. Chamfer. So this is how we do design for the suspended floors. So you repeat the same process for the other sections of the building. So let's take this as an instance also. So in this instance, the actor doesn't have provision for the duct. So in that sense, we'll be considering the web wall, which is a 9-inch block. So let's change our layer again to our cold water supply. Okay, let's paste our riser again. So our riser will be placed somewhere around here, and from our riser L enter, we'll be able to create our main, while we create our internal network all over. So L enter again. Yeah. So in this instance, being a visitor's toilet, we are not required to design for the water heater. However, the next process is just to consider where the risers are coming from. Specifically, since we are using a grand distribution network. So the way I do achieve this is that I will highlight all the risers, and since I've already aligned my hiding lines over here, so I'll use this hiding line CP to copy to the ground floor, F3, while I come over here and I paste. So with this, I'll be able to determine where the risers will be attached to from the ground floor, which implies my riser will be coming from this axis, F3 off. So with this, I'll be able to adjust my main for the ground floor so that the pipes won't be touching each other. M enter, EX extend, enter, close. So likewise for this other part, this one eventually entered to the duct. So we have our riser here. So let's take it inside. So this is just the basic or like a compendium video to the entire risers initiatives. However, it follows the same principles we designed for the internal network. Here in Nigeria, we rarely build above 2 to 3 suspended floors. So our riser doesn't go more than this. So likewise for the riser diagram again, for the entire spaces that is using plumbing fixtures, So for this project, I only have approach view and the rear view. Here is the building. So this is my water supply network. I only have the approach view and the rear view. So in our next video, I'll be elucidating about the pipe sizing, which is the major consideration for every water supply network.